All right, today we're going to talk about multiplying with exponents. Now I'm going to start with the rule, and then we'll take a look at where it comes from. So the rule is, if you're multiplying numbers that have the same base, and we learned what that means, what that word means yesterday, then you're going to add the exponents. So let's look at this problem right here. 3 to the 5th power times 3 to the 4th power. Now the base of each one of these exponentials is 3, and that's what that word means. It's the number that's being raised to a power. So what we have is we have a multiplication problem. We have two numbers that have exponents, and they have the same base. So let's write it out. If we expand it like we talked about yesterday, 3 to the 5th power, what it actually means is 3 times 3 times 3 times 3 times 3. 5 threes, basically. Now we are going to multiply that times 3 to the 4th power. Now that means 3 times 3 times 3 times 3, 4 of them. So if I take 5 threes and I multiply 4 more threes, if you add them all up, you have a total of 9 threes that are being multiplied together. That's 3 to the 9th power. Now where that 9 came from is by saying, well, I have 5 threes here, I have 4 threes here. If I multiply it, just group them all together, 5 plus 4 is 9. So basically, you are multiplying 9 threes total, and you end up with 3 to the 9th power. Now, I multiplied it all out just to show you where the rule comes from. You don't need to do that every time. I'm not saying for each one of these problems you need to write out all the threes and add them all up or anything like that. What we're going to do is we're just going to use the shortcut. We're just going to add the exponents. So for example, if I did 3 to the 5th times 3 to the 3rd, I changed the problem a tiny bit. I basically just add those exponents. I say I'm going to leave the base. I'm not going to multiply the 3. I don't do 3 times 3 is 9. That's a common mistake. You leave the number that's being multiplied, the base. Leave that as a 3, and then just add the exponents. 5 plus 3 is 8. So for this question, the answer would be 3 to the 8th power. And I can put any numbers I want in there. As long as the base is the same, all I do is add the exponents. Now this same rule also works with variables. So instead of 3 to the 5th, or 3 to the 4th, or 3 to the 3rd, you might have x to the 10th power, or y to the 3rd power. That works fine too, as long as it's the same base. So if I have x squared, or x to the 2nd power, times x to the 7th power, I can just leave that base, x, and add the exponents. 2 plus 7 is 9. So this rule works for anything. As long as it's the same base, it doesn't matter if it's a variable or a number, you can always just add those exponents. And what you can do is you can combine it. You can have one problem that maybe has a number part and a variable part, or maybe more than one variable. It might have a number and an A and a B and a C or something like that. Just do each one separately. So however many variables there are, just do it each one as a separate problem. If there's a number part, or what we call a constant part, do that as part of the problem too. So this will be our last example for today. This is a multiplication problem. We have 5x squared y to the 5th times 3x cubed y to the 4th. So when I look at this question, what I say to myself is I'm really doing 3 separate problems here. I'm going to do the number part first. That's 1. I'm going to do the x part second. That's 2. And I'm going to do the y part third. So let's kind of separate it. I'll go by colors here. The first thing I do is the number part. I have a 5 times 3. I'm going to write it out. 5 times 3. Okay, then in the middle I have some x's. I have an x squared times x cubed. And then finally we have our y's. I have y to the 5th times y to the 4th. Now let's put it all together and this will be our final answer. So the number part is easy. 5 times 3 is 15. That's just going to get me an answer. For the other two parts, we're going to use the rule we just learned. We're going to add the exponents. So I do x squared times x cubed. I add those exponents. 2 plus 3 is 5, so I get x to the 5th power. And then with the same thing with the y's. I'm going to leave the y. I have y to the 5th times y to the 4th. 5 plus 4 is 9. And that's my final answer. 15 x to the 5th y to the 9th power. Let's do one more example here. So let's evaluate this multiplication problem right here. 7ab to the 8th times 2a to the 4th. And what I see is kind of like our last example, 3 separate problems. So I have, and I'll separate them again, I have the number part first. I have 7 times 2. Then I have the a part second. I have an a all by itself, no exponent, times a to the 4th. Now for the last part, I have a b to the 8th times nothing. So I'm going to leave that. It's still going to be part of my answer, but I'm not going to add any exponents or anything. So two things happen here. On the number part, again, the number part's easy. 7 times 2, that's 14. Now on the a part, we had an a all by itself. So remember, we've talked about exponents already this year. When you have a variable all by itself, there's a hidden exponent of 1. So a times a to the 4th actually means a to the 1st power times a to the 4th. And when you add those exponents, you get a to the 5th. Then the b to the 8th, I'm just going to leave as part of my answer. I'm not going to change it at all. But it is part of my answer. It is going to stay there. So the final answer for that one is 14a to the 5th power, b to the 8th.